Once again, welcome to all. Till now we have discussed about the exam pattern and the topics of first year syllabus. Now let me start a chapter, introduction chapter. Okay, I want to start unit 3, that is motion in a straight line. Why? Because after completing all the chapters, let me go through the importance of physics and units and dimensions. Because if you know about these all topics, then we can understand what is physics and importance of the physics in our daily lives and units and dimensions. But let me start from unit 3 onwards. What is unit 3? Unit 3. I think all of you know. Why? Because we have discussed about the topics. Unit 3 is motion in a straight line. Motion in a straight line. Okay. In this class, I want to teach the basic foundation for this chapter. Okay. First, let me discuss about the important topics in this one. Important topics. What are the important topics to know in this one? What is scalar? What is vector? What is distance? What is displacement? What is speed? What is velocity? What is acceleration? What is acceleration? These are the important topics for this lesson. Okay, motion in a straight line. Okay, scalar, vector, distance, displacement, speed, velocity, acceleration. These are very important topics to understand total chapter. In every chapter's introduction class, I will teach the basic foundation for the chapter. Then afterwards we can go deep into the chapter. Okay, let me discuss these topics. First one is scalar. We should know what is a scalar. What is a scalar? Scalar is a quantity. Scalar is a quantity which has no direction, but it maintains some magnitude. It maintains some magnitude. It has no direction. It do not maintain any direction. Maybe it may travel like this in zigzag position. Look, once it travels like this, once it travels like this, once it whatever the direction will be, but it reaches the final point. Okay, so it maintains some. It do not maintain any direction, but it has some magnitude. It has some magnitude. Okay, magnitude means what's the magnitude meaning? Some value. Okay, quantity has some. You're traveling some. Body is traveling from here to here, but it means it is covering some path. The path is there. What is the length of the path? That is known as the magnitude. Length of the path is known as the magnitude. What is its magnitude? Let it be, for example, 50 meters. For example, this is 50 meters. It is not maintaining. Excuse me. It is not maintaining any distance. It is not maintaining any direction. It is not maintaining any direction, but it is maintaining some magnitude. It is maintaining some value. Okay, some value, path value it is maintaining. That is known as the magnitude. So from this we infer that, what do we infer? Scalar is a quantity which has magnitude but no direction. Please remember this clearly. Scalar is a quantity which has only magnitude but no direction. Only magnitude it has, but no direction. Okay, that's it. This is about the scalar. Okay, it has magnitude but no direction. Let me write it here. A scalar is a quantity which has magnitude but no direction. It has no direction. It has no direction. Very important. No direction. It has no direction. But it has some magnitude. It has some magnitude but no direction. You can tell what is the scalar means. Has magnitude but no direction. Has magnitude but no direction. Remember this one. Then read about what is a vector. Vector. Okay, it is also one kind of quantity which has both magnitude and direction. It has the direction, some direction. It maintains some direction and it maintains some magnitude. That is said to be a vector. That is said to be a vector. So I think I did not use examples for scalar. Scalar examples for what? Examples. Scalar examples. What are the examples? Distance. Distance. Okay. Then afterwards speed. Then afterwards work done. There are so many scalar quantities, etc. Okay. These are the scalar quantities. Examples I am giving. We will go further deep into these work done, distance, speed, like this. Many quantities are there. Then we will go into those topics afterwards. Okay. This. Okay. These are the examples like that. Okay. Of scalar. Then what is a vector? Now only I told you. What is a vector? Come on, tell me. Vector is a quantity which has both magnitude and direction. I think I did not show the figure. If this is starting point and this is the final point at the time, it is maintaining some direction. Some direction it is now maintaining. It is maintaining some direction. It is maintaining some. It is not traveling like this, like this, like this, like this or like this. But it is maintaining some direction. It is maintaining some direction. Direction is there. One direction. You can tell that as east if you think. East. This is the east direction of us. Okay? That's east. Let it be east. For the example, this is Miryalaguda. This is Vichayawada, you think. Okay? At the time. So some direction it is maintaining. If you are going on a plane, aeroplane, at that time, it maintains some direction if you think. If you go by bus, you will maintain some like this, it's traveling like this and reaches here. This is the distance. Okay? For example, I am telling. Okay? So, this is the displacement. It is maintaining some distance and it is having some, it has some magnitude, for example 90 kilometers. For example 90 kilometers. This is maintaining some magnitude and some direction. Direction, I am giving you, this is the direction. Okay, from this to this position. It is not moving in zigzag way. It is maintaining some distance. Sorry, some direction. Okay, that's it. Let me write in words. A vector is a quantity which has both magnitude and direction. Which has both magnitude and direction. It has both magnitude and direction. That is said to be and examples. What are the examples for this one? I think this all you know in your 9th and 10th class. Only one is displacement. One is velocity. One is acceleration due to gravity. These are all vector quantities. Why? Because they maintain some direction and they maintain some magnitude. That's why these are the examples for vector quantity. Okay. Let me erase. Did you complete? Please maintain one good notes, okay, fair notes, and write them very neatly for further purpose, for the revision purpose. These are very useful for your entire, from here to if you go to engineering also. This is very important. Whatever the topics I am telling for the introductory classes, those are very important. Okay? Then, distance. Excuse. Distance. The path traced by an object in any direction and maintaining some path length is known as a distance. What did I tell you? The path traced by an object in any direction by maintaining some path length. Some path length is known as distance. So, the path traced by an object in any direction but maintaining some path length. అంటే ఇక్కడి నుంచి ఇక్కడికి మెజర్ చేస్తాం, ఇక్కడి నుంచి ఇక్కడికి, ఇక్కడి నుంచి ఇక్కడ. బట్ ఇట్ ఈస్ నాట్ మెయింటైనింగ్ ఎనీ డైరెక్షన్. ఒక డైరెక్షన్ అనేది మెయింటైన్ చేయట్లేదు. But it is reaching some point here. Okay, this is known as a distance. It is not maintaining any direction, but it is maintaining some magnitude, some path length. For example, this is 60 meters, and not maintaining any direction. Then that is said to be distance. Then that is said to be, here A point is there, here B point is there. It is not maintaining any direction, but it is reaching that point in some other directions, different directions. That is said to be the distance. Okay. The path traced by an object in any direction the path traced by an object in any direction without maintaining direction. I can tell without direction. Without maintaining any direction. The path traced by an object in any direction by covering some path length. Is known as distance. The path traced by an object in any direction without maintaining any direction, by covering some path length is known as distance. So I told you already, this is the initial point, this is the final point. It has to reach here, but it does not maintain any direction. It does not maintain, but it reaches this point. Okay, by covering some path length. That is said to be the distance. Okay, good. This is it. Unit of distance is unit of distance. What is the unit of distance? Unit of distance, I think all of you know. Unit of distance is nothing but unit of length. How do you measure your length? Okay, with what? Measure scale only, no? In that what you have with centimeters, meters, millimeters, kilometers, like that. So what is the SI unit of SI unit is what? SI unit is meters or kilometers. Okay. CGS unit is what? CGS unit is centimeters. Centimeters. CGS unit is centimeters. SI unit is meters or kilometers. Okay. Unit of distances. Okay. Next one is displacement. Displacement. What is displacement? What is the displacement? It is the path traced by an object in one particular direction and maintaining some path length. Okay? It is the path traced by an object in one particular direction by maintaining some path length. Okay? That is known as a displacement. Okay? It is the path traced by an object in any one particular direction, in any one particular direction, and maintaining path length. Is known as displacement. Maintaining path length is known as the displacement in any one particular direction. Or non particular direction, it may be east or west or north or south or southeast or southwest or northeast or north. So some one direction should be their own, any one direction, not in a zigzag way. That is known as the displacement. It should have some value. Okay, it should, the path length should be some value. Sometimes the path length will be also 0 in displacement case. Let us see how. If this is Miryalguna, this is Hyderabad. Okay, so you're going by a car. You think by a car or drone. If you think you created a drone and you may to pass on in a straight path. You may to pass in a straight path. Okay, you created a drone. Okay, and that drone is allowed to pass only in one direction at that to reach Hyderabad. Means you are maintaining some direction here and path length. And let it be around 60 kilometers. You think 60 kilometers. So it is maintaining direction and it has some path length 60 kilometers. That is said to be the displacement. Okay, that is said to be the displacement. Did you understand it clearly? Okay, displacement is nothing but it is a path traced by an object in any one particular direction and maintaining path length. It is known as displacement. I told another one, something I told before this sentence. What did I tell you? So displacement sometimes is equal to 0. How? Let us see that one. If this is the initial point A, a body is traveling in north direction, then afterwards east direction, then afterwards south direction, then afterwards some other direction, southwest direction, then afterwards west direction, then afterwards northeast direction, and coming to the initial point. Okay, this is the once again reaching to the initial point. This is the A, this is B, this is C, this is D, this is E, this is F. A body is traveling from A to B, B to C, C to D, D to E, E to F, and once again F to A. So, yeah, you can get the distance trace. Let it be 20 meters. Here also 20 meters. Here also 20 meters. Here one, let it be 30 meters. Here 15 meters. Okay. Here, let it be once again 30 meters. If you think What is the distance traced by this one? 20 plus 20, 40, 40 plus 20, 60, 60 plus 30, 90, 90 plus 15, 105, 145. The distance is 145. But what is the displacement here? What is the displacement here? Anyone? What is the displacement? So, the displacement is the path traced between the initial position and the final position. Initial position, I told before, this is the initial point, this is the final point, A, B. The path traced in one particular direction from initial point to final point, that is said to be the displacement. Here, what is the initial point? Initial point is A. Initial point is what? Initial point is A. And what is the final point? Final point is also A. Final point is also A. It is coming, okay, going like this, going once again, coming to reaching the same point, same initial point. At that time, what is the path between those A and A? 0 only, no? Okay, 0 only between those two. At that time, the displacement in this case is equal to, implies displacement is equal to 0. Okay, did you understand how the displacement is 0? In few cases, the displacement is 0. Try to understand clearly the concept. Here it's nothing. What's there? It is starting from A, then B, then towards C, then towards D, then towards C, then towards F, then towards A. Once again, reaching the initial position. So what happens here? What is the meaning of displacement? The path traced between the initial position and the final position. Okay, the path between the initial and the final position, that is said to be the displacement. Is there any path, okay, traced between A and A? No. A and A is same point only. Is there any path change there? No path change. That's why the displacement is equal to 0. Good. Did you understand clearly? Try to understand. Once again go through the video. If you can't understand, once again go back and once again revise that one. It is better to review the video many times as many times as you can, so that you can understand clearly. Please try to do like that. Okay, understood now displacement. So let us see. Let us see. What is distance by displacement value? You consider this as an initial point, this as a final point. This you consider as a and this you consider as B. For example, if you are going on a bike, okay, in different directions, like this, if you are going, okay, like this, you are going and you are reaching some point B. Okay, what is this? Try to tell. Okay, what is this? Is this a distance or displacement? Yeah, you're right. It is a distance. It is the distance covered by the body or bike, whatever the bike you are going. Okay, so this is the distance covered. If you think you're going on your drone, you created your drone on which a man can travel. Okay, man can move. Okay, at the time you created your drone. The drone, it has to travel in. If you make the drone to travel in only one direction, that it will be going in this direction and reaching this point For example, the distance, whatever the distance covered here is around 60 kilometers. You think this is the 60 kilometers distances, but if you see this black line, very small length is very small. Okay, that is around maybe 20 meters. You think this is around 20 meters, which black line is around 20 meters, black line. Okay, what is the distance here? Distance is what? 60. And what is the displacement? 20. That is equal to 3. What did you infer from this? Distance is always greater than displacement. Distance is, okay, always greater than displacement. Okay, sometimes distance is also equal to displacement. How? Let us see. This is A and this is B. Your friend created a device which can move only in one direction from here to here. Okay, it moves like this. Your friend. You also created another device. That you made to travel in this direction only. Okay. If you see this one, this it is traveling in the single direction. This it is traveling in this direction only. So here you cover some path. Okay, you maintain some direction. It may be considered as distance or displacement in this case. Okay, so at that time distance is equal to displacement. Distance is equal to displacement. Okay, only one path is there at the time. Okay, you can consider this as a distance or displacement. Okay, I told you. What did I tell you? Distance means it is not maintaining any direction, whether it may maintain direction or may not maintain direction, but that is said to be the path traced is known as the distance. The path is traced, that's why that is said to be distance, but it is maintaining some direction, that's why that is a displacement. Try to understand. Here distance is equal to displacement. In that case what it will be, for example, this is 20 meters. Okay, what is distance? 20. By displacement is what? 20. That is equal to 1. At that time, from these two, what do you infer? At the time, distance by displacement is greater than or equal to 1. Greater than or equal to 1. And the time, it cannot be less than 1. It cannot be less than 1. Okay, that is for today. I think you enjoyed the class, and I'm logging out until we meet once again. Okay, bye.